Hey guys, today we're going to do 5 theorems about roots of polynomial equations. So you will be able to solve equations using the rational root theorem, and you will be able to use the conjugate root theorem. So one way to find the root of a polynomial equation p of x is to guess and check. This is very inefficient way to find, and there's a way to minimize the number of guesses or possible roots. And the rational root theorem does that. So if we have our polynomial p of x with integer coefficients, there are a limited number of possible roots. P of x equals to 0. So there are a limited number of possible solutions where our polynomial is equal to 0. So our integer roots must be factors of a sub 0, or our constant term. And our rational roots must have the reduced form p over q, where p is an integer factor of a sub 0, and q is an integer factor of a sub n. So, finding a rational root. What are the rational roots of 2x cubed minus x squared plus 2x plus 5 equals 0? So here, the only possible roots, rational roots, have the form the factor of the constant over the factor of the leading coefficient. The constant factors are positive 1 and negative 1, positive 5 and negative 5. The leading coefficient factors are positive and negative 1 and 2. So the only possible roots, rational roots, are 1 over 1, which is 1, 5 over 1, which is 5, 1 over 2, which is 1/2, and 5 over 2, which is 5 halves, and positive and negative for all of those possible roots. Then we have the table that shows the values of the function y is equal to p of x for the possible roots. So we plugged in 1 and negative 1, 5 and negative 5, 1/2 and negative 1/2, 5 halves and negative 5 halves, to see where our y value equals 0. And since we get a y value of 0 at x equals negative 1, the only rational root of 2x cubed minus x squared plus 2x plus 5 equals 0 is at negative 1. So once you find one root, we're going to use synthetic division to factor the polynomial and continue finding roots and dividing until you have a second degree polynomial, because once we have that second degree polynomial, we can either factor or use the quadratic formula to find the remaining roots. So for number 2, we're going to use the rational root theorem to find the rational roots of 15x cubed minus 32x squared plus 30x plus 2 equals 0. So we know the coefficients and the constant term of the polynomial, which is positive and negative 1 and positive and negative 2 are the constant term factors. So p, you have positive and negative 1 and positive and negative 2. Then for q, or the leading coefficient factors, are positive and negative 1, positive and negative 3, positive and negative 5, and positive and negative 15. So the possible rational roots are 1 over 1, which is positive and negative 1, 1 over 3, 1 over 5, and 1 over 15. Then we also have 2 over 1, 2 over 3, 2 over 5, and 2 over 15. So, test each possible rational root in our original polynomial, 15x cubed minus 32x squared plus 3x plus 2 until you find a root. So first we'll test 1, and we'll plug in 1 into our equation, and that does not equal 0. And then test 2, 15 times 2 cubed minus 32 times 2 cubed, 2 squared, plus 3 times 2 plus 2 is equal to 0. So since 2 works, 2 is a root. So now we're going to factor the polynomial using synthetic division. So 2 is our root, so we're going to set up synthetic division with 2 on our outside. 15, negative 32, 3, and 2. Two times 2 is 4. 3 plus 4 is, this is negative 2, so negative 4, negative 1, negative 2, 0. And this turns to 15x squared minus 2x minus 1. And it was this times x minus 2. Since 15x squared minus 2x minus 1, we can go ahead and factor that. What multiplies to negative 15 and adds to negative 2? Negative 5 and 3, making it 15x minus 5 times 15x plus 3. I can divide this one by 3 and divide this one by 5. Get 5x minus 3 times, 3x minus 1 times 5x plus 1. So we have x minus 2 times 3x minus 1 times 5x plus 1 is all equal to our original polynomial. So we have the other roots. We have x equals 2 is a root, x equals 1/3 is a root, and x equals negative 1/5 is a root. Now we have to remember from lesson 4.8 that a complex numbers, a plus bi and a minus bi, were conjugates. Similarly, the irrational numbers, a plus square root of b and a minus the square root of b, are conjugates as well. If a complex number or an irrational number is a root of a polynomial equation with rational coefficients, so is its conjugate. So the theorem, conjugate root theorem, says if p of x is a polynomial with rational coefficients, then irrational roots of p of x equals 0 that have the form a plus the square root of b occur in conjugate pairs. That is, if a plus the square root of b is an irrational root with a and b rational, then a minus the square root of b is also a root. The conjugate root theorem also states if p of x is a polynomial with real coefficients, then the complex roots of p of x equals 0 occur in conjugate pairs. That is, if a plus bi is a complex root with a and b real, then a minus bi is also a root. So using the conjugate root theorem to identify roots. A quartic polynomial p of x has rational coefficients. If the square root of 2 and 1 plus I are roots of p of x equals 0, what are the other two roots? So since p of x has rational coefficients and 0 plus the square root of 2 is a root of p of x equals 0, following the conjugate root theorem, the 0 minus the square root of 2 is also a root. And since p of x has real coefficients, and 1 plus I is a root of p of x equals 0, it follows that 1 minus I is also a root. So the other two roots are negative square root of 2 and 1 minus I. Using conjugates to construct a polynomial. What is a third degree polynomial function y equals p of x with rational coefficients so that p of x equals 0 has roots negative 4 and 2i? So we're going to think about our roots. We know that we have x plus 4, and since we have x 2i is a root, we have x minus 2i. And since 2i is a root, then we also know that negative 2i is a root, so then we have x plus 2i. And we are going to multiply the complex conjugates. X squared plus 4, and then multiply again and get x cubed plus 4x plus 4x squared So the equation x cubed plus 4x squared plus 4x plus 16 equals 0 has rational coefficients and has roots negative 4 and 2i. So the correct answer is C. So this next theorem is going to be a connection between the roots of a polynomial equation and the positive and negative signs in the standard form. So Descartes' rule of signs, we're going to let p of x be a polynomial with real coefficients written in standard form. So the number of positive real roots of p of x is either equal to the number of sign changes between consecutive coefficients of p of x, or is less than that by an even number. The number of negative real roots of p of x equals 0 is either equal to the number of sign changes between consecutive coefficients in p of negative x, or is less than that by an even number. In both cases, count multiple roots according to their multiplicity. So we're going to use Descartes' rule of sign. So what does it tell you about the real roots of x cubed minus x squared plus 1 equals 0? There are two sign changes. We go from positive to negative. So here we go from positive to negative. And then we also go from negative to positive. Therefore, there are either 0 or 2 positive real roots. So there are 2 or 0. If we think about what the graph of a cubic functions, we have 0 or 2 turning points. because the graph already shows two turning points, it will not change direction.